tiny moment. If somebody weighed 199 and now they weigh 203, we can make that assumption that they weighed 200 at some point in there, right? So this is essentially the intermediate value theorem. Okay, this assumption that if I was here and now I'm here, I had to pass this point somewhere in the middle. That's our intermediate value theorem. So let's look at what it looks like in mathematical terms. Okay, so make this fit on the page here. I don't know what those right there are. I kind of want those to go away. Can I make them go away? Down there. All right. Intermediate value theorem says if f is a continuous function on the closed interval from a to b, and d is a number between f of a and f of b, then the intermediate value theorem guarantees that there is at least one number c between a and b such that f of c equals d. Oh gosh, that's so many letters, right? So many letters and so few numbers in this problem. But let's draw. I think drawing a picture really helps. So we have a closed interval from a to b. So that means you got an a here on the x-axis and you got a b somewhere else. And a is lower than b. And we have a function f that is continuous. So I'm just going to put a dot here and a dot here, and it really doesn't matter what happens here in between these dots, but we know it's continuous. Okay, so if I want to label these two pieces, f of a and f of b, which axis should they be on? Not the x-axis. They are on that y-axis. I actually have my y-axis labeled as f of x. So f of something, like you'll see sometimes, like if they want you to graph the point, they might do like 3f of 3, if you're thinking about it with numbers. That just means like the number you plug in when you get 3. So f of something is always on your y-axis. So if I put f of a would be right here. Because if I plug in a, this point right here is my x-coordinate, I get f of a. Those are the coordinates for that point, a and f of a. So f of b would be right here. All right? If I think about the coordinates of this point, this is b, f of b. So what's happening here is I've got a continuous function. I'm looking at some closed interval from a to b, and it tells me d is a number between f of a and f of b. So d right here is between f of a and f of b. So it's somewhere, let's put it here. B anywhere, right there. Okay. What the intermediate value theorem is telling us here is that the intermediate value theorem guarantees that there is at least one number, c. Oh gosh, another letter. I'm running out of colors for these letters. All right, let's do c. Where is c at? It's between a and b on the x-axis, right? So c is like right. C is here for this particular drawing that I've given, because it tells us f of c has to equal that d value. So it's saying there must be some time that you cross that line right there. It's like you can think right here is Jeremy's weight. Here's when he weighed 199. Here's when he weighed 203. D right here is 200. He had to pass it. Now Jeremy could have, like the graph could have done other stuff. I could fix this graph here. Let's say Jeremy could have gained the weight, went on a little diet, dropped back down below 200, then went right back up. That's how diets seem to work for me. You drop the weight, then go back up. It could happen more than once. There could be more than one number that would fit that C definition here. But it has to happen at least one time. Okay? So essentially all this means is that you had one value here, another value here, you had to cross some value in between. Right? We could switch this around. It could be weight loss. Jeremy could be losing weight. He could have started at 209 or whatever and ended up at 193. Still, the same fact would have to be true. He weighed 200 at some point right there. Now, the big condition that we have to know, and it's going to be a big deal, F has to be continuous. If F is not continuous, this is not true. Right? If F is not continuous, then I could have a graph that looks like this. I could have a graph right there. It goes through F of A. I got a closed dot right here. Got an open dot right here. Keeps on going, right? Did I ever pass D right there? I did not touch D because my function's not continuous. It just skipped right over D. So you have to have a continuous function for this to be true. But let me get rid of that because that's not what we're talking about right now. So here is an application of intermediate value theorem that we can use. Explain why the function f of x equals e to the 2x minus 5 must have at least one 0 on the interval from -1 to 2. Now, this would be a non-calculator question. And it doesn't ask us to find the 0. It asks us to explain why you have to have at least one. Okay? So, first of all, let's make sure we got terminology right. What in the world is a 0? Let's do a little definition there. What is a 0? It is an x-intercept. Okay, so if at an x-intercept, what does your y value equal? 0. Or I could have said it, another way to say it is f of x equals 0. Right. So, if I'm looking to see what happens here, first of all, I can only apply an intermediate value theorem if this is a continuous function. Is e to the 2x minus 5 continuous? It's continuous. It's just it's known that exponentials are continuous functions, right? I don't have denominators. I don't have square roots. I don't have natural logs. Those are the things that are going to give us trouble. So I'm going to have, first I'm going to say f of x is an exponential function. So f of x is continuous for all real numbers. Or from negative infinity to infinity, if you like. That is important. Now, it doesn't have to be continuous everywhere. It really only has to be continuous from -1 to 2. If you say it's continuous from -1 to 2, that's fine. But if we say all real numbers, that also includes that. You could do either one there. So if I find f of -1, if I plug in -1, I get e to the 2 times -1 minus 5, which is e to the -2 minus 5. And I don't have a calculator on this, and I don't know what that is. But I could do 1 over e squared minus 5. Now, I don't know exactly what that is, so I'm gonna move on. I'm gonna do f of 2. So f of 2 is going to be e to the 2 times 2 minus 5, which is going to be e to the 4th minus 5. Ooh, I don't know what that is either. Okay, so this is not good because I don't know either one of those and I can't use my calculator on those. But I really don't have to know what those values are. I'm looking for a 0. What does my y value equal whenever I have a 0 or an x-intercept? At an x-intercept, y equals 0, right? So if I can say that, well, at -1, my point was down here, and at 2, my point was up here, and this is continuous, what's it got to cross? It's got to cross 0, all right? So, let's 1 over e squared minus 5. E is 2.71828 something something something. 1 over e squared minus 5. Positive or negative? It is going to be negative. I'm going to just put a less than 0 here to show I know. I don't know what it is, but I know it's negative. What about e to the 4th minus 5? So 2.71828 to the 4th minus 5. That's definitely greater than 0. I don't know how much, but I know it's greater than 0, right? So, what the conclusion I can make here, because this is a negative number, and I'm going up to a positive number, and this function is continuous, tells me I got to cross the x-axis somewhere, right? So, this is how you're going to state it. I'm going to say since my negative number comes first, f of -1 is less than 0, less than f of 2. So 0, I'm saying 0 has to be between f of -1, which is some negative number, and f of 2, which is some positive number, right? By the intermediate value theorem, and then what you're going to do, you're going to say there must be some value I guess I should say x value, some x value on our x coordinates. We're looking from -1 to 2, such that f of x equals 0. So f of x has a 0 on -1. It's a negative right there, -1 to 2. We did. So much writing. But let's go back through and look at. I'm gonna point out the stuff you have to have for these. Okay. So number 1, most important, you have to show or say that f is continuous. If it's not continuous, intermediate value theorem does not apply, and therefore you cannot make any assumptions about what's happening here, and you can't do the problem. Okay. The second thing you want to do is find values of endpoints. So in this case, that was f of -1 and f of 2. Sometimes you can't find exactly what the value is. Sometimes you'll get numbers. You'll have -7 and +15. But sometimes it's like this where you can only tell maybe they're positive or negative. You can tell it's higher or lower than a certain number. Find values of endpoints. State that f of, I'm going to use an a and a b here, is less than your value less than f of b. And then use, I'm going to call it IVT, but please do not call it IVT when you're writing out the whole thing. Intermediate value theorem to make conclusion. So IVT is intermediate value theorem. Please do not write that on anything you turn in to me. Don't write IVT. Write it out, intermediate value theorem. Because there's also going to be a mean value theorem, and IVT and MVT are really easy to get mixed up. It helps if you write out the name of it each. Okay, so continuity, values of the endpoints, showing that those endpoints are above and below whatever you're looking for, and then making your conclusion with intermediate value theorem. All right, so let's look at this one. On the interval from -1 to 4, prove that the function f shown below, for the function f shown below, there is some c such that f of c equals -3. I should say some c on the interval, such that f of c equals -3. Justify your answer. All right, first of all, I have got to talk about continuity. If this is not continuous from -1 to 4, I can't do it. Does this function have any discontinuities? It has one. It's at 5. Is that between -1 and 4? Okay. F of x is continuous everywhere except x equals 5. Therefore, f of x is continuous on the interval from -1 to 4. Okay, so that's the first thing. We've got to state continuity, because if it's not continuous, the intermediate value theorem doesn't apply anyway. You could just jump right over a value, right? So if 5 was in that interval, we wouldn't be able to do this problem with intermediate value theorem. We'd have to have some other method, which we don't have yet, so you won't really see that happen. All right, then what was the second thing I said we had to do? Values of endpoints. So -1 and 4 are those endpoints. So we're going to do f of -1. Oh, let's see. F of -1 is going to be -1 squared minus 9 over -1 minus 5. So 1 minus 9 over -6 is going to be -8 over -6. So 4/3. And then we got to do f of 4. F of 4 is going to be 4 squared minus 9 over 4 minus 5, which is going to give us 16 minus 9 over -1. So 7 over -1 is -7. So I think it's helpful to think about what we're trying to look at here. Graph is not perfect there. So what I've just found, right? -1 over here to 4 is where I'm looking, right? And I found at f of -1, I'm up here at like 4/3. right? My graph goes through that point I really drew this graph badly. Right here is -7. At 4, -7, my graph goes through here, so my graph has to go through these points. I also know it's continuous, so it's got to do something where it goes through those 2 points, right? What value are they wanting us to prove we pass? -3. That's f of c equals -3. -3 is right here between our 4/3 and our 7. So there's got to be some place in the graph I've drawn, it's right here, where we cross that -3 line, right? So be careful whenever you're doing this. This was our second step. We have to show those values of the endpoints. The third step is that you've got to show that the value you're looking for, in this case 3, is between those two values. Which one's lowest, f of 4 or f of 1? F of 4. So when you write this, make sure you'll say since f of 4 is less than, -3 is the target value, that's what goes in the middle, less than f of -1. As long as you have everything labeled well, you can do that. So let's talk about some options on this. As long as up here you labeled this f of -1. If you didn't label this f of -1, if you don't, you must label this. If you label it like this, it is okay to, instead of this, write -7 less than -3 less than 4/3. But these values have to be labeled as f of -1 and f of 4. Okay. Another option here. Some students like to do it this way. I kind of like it. -7 equals f of 4, which is less than -3, which is less than f of -1, which equals 4/3. Now that's a little long. But what it does is it puts that value included here. It kind of combines those two things because f of -1 does equal 4/3. So some students like to write it that way. Any three of these are perfectly valid options as long as you have clearly labeled that this is f of -1 and this is f of 4. If you just did your work up here, if you didn't write this stuff and you just got 4/3 and -7, and then you go down here and write this without showing it's f of 4 and f of -1, not going to give you credit because you're not showing it's at those points that we're concerned with. So make sure that you label everything. If you're plugging 4 into an equation, you need to show that you're doing that by doing f of 4 for that. All right, so since this is the case, we could say any of these three things right here, right? Any of those are options, those three things. Since that is true, by the intermediate value theorem, and then I like to, especially whenever it's giving you this problem, I like to just restate what the problem said. There is some C such that f of c equals -3. Now we do need to say on the interval. There is some C, I'm going to put on the interval from -1 to 4, such that f of c equals -3. And that is our fourth thing, making that conclusion using the intermediate value theorem. These problems are almost always on the FRQ section. They put these on the AP exam. I've seen this several times on the actual FRQ for the AP exam. So it does show up, and you have to state continuity, find your endpoints, show that those endpoints are on either side of whatever value you're talking about, and then make your conclusion for that. Okay, if you can follow that formula, you'll have it. Now, sometimes these show up in multiple choice questions like this. Let f of x equal x plus cosine of x over 5 minus 3. The intermediate value theorem applied to f on the closed interval from negative 9 to 4 guarantees a solution in negative 9 to 4 to which of the following equations? Now, is this supposed, I think this is supposed to be calculator active. I'm pretty sure this one is supposed to be calculator active. Okay, because those are not unit circle values. They could give you the same problem and use unit circle values and it wouldn't be calculator active, but I'm going to use the 84 because I don't have the 89 downloaded yet because I keep forgetting to ask them to do that because I don't have the power. So I'm going to just use the 84. It's just basic plugging stuff in. So actually, no, I'm not. I'm going to use the 89. I'm going to show you guys something cool on the 89 because I need to be teaching you these cool things about the 89 as we go along. Put that equation in your y1 for me. So everybody get your calculator out. Put that equation in your y1. Okay, so, oh gosh, I'll zoom in there and brighten that up. Let's see that. Okay. All right, so you're going to go second F1, or no, green button F1 to go to y equals, you're going to type in x plus cosine x over 5 minus 3. I just want to show you something cool. You don't have to do it this way. You could just type it in, okay? So, intermediate value theorem is going to guarantee one of these things. For intermediate value theorem, I'm looking at the values at the endpoints, right? So, I need to plug in negative 9 and I need to plug in 4. And since those are not unit circle values, we're going to use our calculator for this. Watch this. This is so cool. If I put it in y equals and go back to my home screen, I need to plug in negative 9. I typed that into y1. So if I type y1, so I just hit the y button and a 1. So that's where this is at. And I do of negative 9. So y1 of negative 9. So the y button is right beside your x button. And then the 1. There's not a special button for y1. I'm just typing a y and a 1. So this is going to plug that into my equation for me. So y1 of negative 9 is going to be this. That doesn't tell me a lot. Hit the green button and enter, and it'll give you an actual value for that. So we're getting over here that f of negative 9 is negative 12.2272. And then I got to plug in 4. So I can just type in y1 of 4. So y1 parentheses 4 close parentheses. And hit the green button before you hit enter so that it gives you a decimal. And f of 4 is going to be 1.69671. Alright, so there is only one of those that must be true according to the intermediate value theorem. It is B, because 0 is the only value that falls in between negative 12 and 1.69. Everybody okay there? All right. Okay, here's just another multiple choice. This one's not calculator active. All right, so let F be a function such that f of negative 3 is less than 9, less than f. Which of the following statements provides sufficient additional information to conclude that there is a value x equals c in the interval from negative 3 to 6 such that f of c equals 9? So A is f is increasing for all x, decreasing for all x, continuous for all x, and that there is a value from 5 to 7 such that the limit approaches 6. Which one of those is it going to be? What has to be true for us to make this conclusion that because we're between these values, we have to have some place where it equals 9? Continuous, right? Continuity is your only requirement for intermediate value theorem, and that's basic. It doesn't use the words intermediate value theorem, but it's saying, hey, we're between here and here, so because these values are above and below 9, you got to equal 9 at some point. That is intermediate value theorem. For intermediate value theorem to apply, you have to have continuity. Increasing for all x does not necessarily guarantee this, because you could be increasing and have a vertical asymptote, or you could be increasing and have, other problems with your graph, but continuity has to happen. All right, we okay there? All right, from 0 to 4, the function shown must have a value x equals c such that. So here, we've got, if we do f of 0, this would be calculator inactive. We'd have 0 squared minus 3 times 0 plus 2 over 0 minus 2, which would give us 2 over negative 2, which would give us negative 1. And if we did f of 4, we would get 4 squared minus 3 times 4 plus 2 over 4 minus 2, which would give us 16 minus 12 plus 2 over 2, which is 6 over 2, which equals 3. So we got a negative 1 and a 3. Which value must happen? Feels like B? It's not B. This is a trick question. It's D. Why is it D? Discontinuity at x equals 2. I actually did forget to check that. Even until I got down here and saw answer choice D, I was like, oh, why is that there? Because this is discontinuous, can we make the assumption that it is 2? If it's not continuous, we cannot. So D is the correct answer on that one. If it's on the interval. So you got to check. So you want to look for that discontinuity. If it's not on the interval, so like if this was the interval from 4 to 8, or if it was x minus, well, really like a 5, because 4 would be at the end point, so you'd still have a discontinuity on that. But if it's not on the interval, you can still apply it, and then B would be your answer. But if it's discontinuous on that interval, you cannot make assumptions based on that. All right. So your assignment comes from the book tonight. And let me look at it real quick. The directions may be a little bit weird on that. Let's see. It's actually 97 and 98. 89 through 92 are ones asking you to explain why there is a 0. So that is, you're looking for like a negative and a positive. I'm okay with you guys using a calculator on this to find those values, because I don't want you to spend hours by doing all that by hand. Although they are ones you could do by hand. For 99 through 102, they are ones where you are proving that particular value, not necessarily 0. for those. Okay. Again, I can live with it if you use the calculator to find f of 0 and f of 5, because those should be things you can do easily, even if you didn't have your calculator. But I want to focus on intermediate value theorem much more than spend a lot of time on arithmetic on that. Okay. So, it will benefit you to actually write all this stuff out on your homework. I know it is a pain, and I know for many of my math lovers out there, you might be thinking, this is not math. Why are we doing this? But the logic behind math and being able to justify why something is true is like the essence of math. It is.